So now that we know that e is roughly 2.7, it's a random number that we call the natural base, it is kind of expected to ask, well, what is the derivative of an exponential function that has e as its base? So that's what we're trying to answer with this theorem over here. So what is the derivative of an exponential function where the base is e? So it turns out that it's very straightforward. The derivative of e to the power of u is literally the same thing again, just copy the problem down, but then multiply it by the derivative of what the exponent was, okay? So this is the idea. So the derivative of e to the u is itself, again, multiplied by the derivative of the exponent. So we're gonna practice that with example number 4. So here we go. It says y equals to 3e to the power of x, and they want the derivative. So they want me to find the derivative with respect of x of the y, which means I'm looking for the derivative with respect to x of the 3e to the power of x. Now, the 3 is a random number, so we just leave it alone. We don't mess with it. And now the question is, how do you find the derivative of e to the power of x? So there, in this case, I have to use the new theorem, the new derivative theorem, okay? This is kind of like a product rule or a quotient rule or a chain rule. It's the same kind of thing. So according to the rule, the e to the power of x, the derivative of that is going to be e to the power of x again, and we multiply by the derivative of the exponent. So what was the exponent? Take its derivative and write it next. The derivative of x is going to be 1, okay? So all those things that we wrote over here are the derivative of e to the power of x. And in this case, the final answer would be 3e to the power of x. So the derivative of 3 to the power of e to the x is literally the same exact thing. And this is the nice thing about the exponential functions, is that the answer to the problem is literally half the time the problem itself.